All right, in this video, we're going to talk about how to use StatDisk.com to complete the samples, well, to complete the actual StatDisk assignment number 3. Okay, so we'll start with the sample problem number 1. In part A, you're given a population with a normal distribution with a mean of 0 and a standard deviation of 1. And here we want to find the probability of a value less than 0.4. Okay, the first thing you have to do here before you use StatDisk is to convert your X value to a z-score. You have to convert each X value to a z-score before you can use StatDisk. And the formula for finding the z value will be this. Z is equal to X, which is your data value, minus the mu, which is your mean, divided by sigma. That's the standard deviation. So in this case here, the X value that we're dealing with is going to be 0.4 minus your mu, the mean is 0. The standard deviation is 1. So if you do 0.4 minus 0, that's obviously going to be 0.4. 0.4 divided by 1 will end up being 0.4. That would be your z-score. You're going to use that to help you come up with that probability for a value less than 0.04. So what we're going to do here is go to StatDisk.com. Okay, and this is the screen for that. And you have to log into StatDisk.com using your email address and the password that you created. Okay, so first thing we're going to do here is go to analysis on the left-hand side at the very top. This time we're going to go to probability distribution. Click on that. Here we're dealing with a normal distribution. So we're going to select normal distribution. And you're going to get this screen on the left-hand side. And on the left, you'll see Z value. You have to convert whatever X value you have to a Z value before you can use this. And the Z value that we came up with in part A is 0.4. You're going to type that in. Okay. Let's see, cumulative area to the left. I'm going to leave that blank. Click on evaluate. Okay. Now it does say less than 0.4. So the one we have to look at in this case is the one under cumulative probs, the one that says left. That would be the probability value for the Z for a value less than 0.4. And in this case, we round the 4 decimal places, so it'll be 0.6554. Okay. Because it says less than, so we have to look at the one that says the cumulative probability on the left, which is this, 0.6554. Okay. Now I'm going to go back to the PowerPoint. And then we're going to go to part B of that sample problem number 1. Here you're given a population with a normal distribution, a mean of 100, and a standard deviation of 15. Here we want to find the probability of a value greater than 117. So in this case, we need to convert the X value of 117 to a z-score using this Z formula before we can even use the StatDisk. So here we got Z is equal to X minus the mu divided by sigma. Your X value is 117. So it'll be 117 minus your mean, in this case is 100. That will be divided by the standard deviation given as 15. So here, if we do 117 minus 100, that's 17. And 17 divided by 15 as a decimal to 2 decimal places will be 1.13. So 1.13 is going to be the z-value that we will use in StatDisk. Okay, so let's go back to StatDisk. All right, we're already under normal distribution still because it is a normal distribution. The z-value here will be 1.13. We're going to type that in. Okay, I can leave the cumulative area from the left blank. Click Evaluate. On the right-hand side, you'll see your cumulative probabilities. Now, it does say greater than 117. Greater than means we need to look at the area on the right. That's this part that I'm highlighting right here. The area on the right, because it's greater than 117. So here, this will be 0.1292. 0.1292, rounded to 4 decimal places. Okay, pay close attention to how many decimal places they want you to round off to. So it'd be 0.1292. Okay, that represents the probability of a value greater than 117. Okay, we're going to continue on with part C. Given a population with a normal distribution, a mean of 98.6 and a standard deviation of 0.62, find the probability of a value between 97 and 99.0. Okay, so here we're finding the probability between these two numbers, 97 and 99.0. Both of these numbers, 97 and 99.0, we must convert to z-scores. So for x being 97.0, we use that formula. Z is equal to x minus mu divided by sigma. Here your x value in this case is 97 minus the mean of 98.6 divided by the standard deviation of 0.62. Now 97 minus 98.6 will be negative 1.6. Negative 1.6 divided by 0.62 will be equal to a negative 2.58. And then for x equal 99, we still use z is equal to x minus mu divided by sigma. And in this case, your x will be 99 minus the mu, which is 98.6. That's your mean. Sigma is your standard deviation, by the way, so that standard deviation is 0.62. 99 minus 98.6 will be 0.4. 0.4 divided by 0.62 to 2 decimal places will be 0.65. Okay. And now we can use StatDisk to find out what our probability is going to be. So back to StatDisk. And it's still going to be normal distribution, by the way. Nothing's going to change. The z-value for 97.0 was negative 2.58. So I'm going to type negative 2.58 in the box for the z-value. And then click on Evaluate. Okay. Now, in this case, we could choose either the left or to the right. I'm choosing the left. So that probability value that you see there for the left would be 0.0049 to 4 decimal places. 0.0049. The 4th decimal value after the decimal point is a 9. To the right of it is 4. It's less than 5, so that 9 stays the same. Okay. And the other z-value, which was for 99, was 0.65. Okay, so 0.65, we type that in. we can leave this blank, click evaluate. Now, if I use the left for the first z value, I need to use the left for the other z value. That to be consistent here. So to 4 decimal places, this will be 0.7422. Notice that the 4th digit after the decimal point is a 1 to the right of it is 5. It's 5 or bigger, so that 1 increased to a 2, so it'll be 0.7422. Okay, now to come up with the correct answer, I have to subtract those 2 probabilities that I came up with for negative 2.58 and for 0.65. Okay, let me show you how to do that. We have to subtract. Okay, I'm going to do this inside Microsoft Word here. So 0.7422 minus 0.0049. And here we can just do this in the calculator. Okay. And you'll end up getting 0.7373 as the final answer. Okay. So pretty much you can just type this in. I mean, just, I just did this. I'm just typing this out in Microsoft Word so that we can see how I'm getting that answer. You have to subtract those 2 probabilities here because basically you're looking for the area in between the 2. So you have to subtract. Okay. All right, so that was sample problem number 1. Now we can move on to sample problem number 2. And that's this. From a 3M privacy filters poll in which respondents were asked to identify their favorite seat when they fly, and N is the sample size, that's 806, X is equal to 492, those are the ones who chose the window seat. Construct and interpret a 95% confidence interval estimate of the population proportion P. So here we're doing a confidence interval estimate of the population proportion. Okay, so now we're going to go back to StatDisk. Okay, now we're going to do something different here. We're doing a confidence interval. So under analysis, you go here, click on that. You're going to see this menu item that says confidence intervals. Click on that. Now here we're dealing with the population proportion, and it's only going to be one sample. So here we're going to click on proportion 1 sample. Click on that. And you're going to see these numbers that you're going to have to enter in, those spaces you're going to have to fill in. Now, we are constructing in this case, a 95% confidence interval. So here, the confidence interval. Now, when you first use this, they're going to give you 0.95 as a default. So 95% will be 0.95 as a decimal. Now, if it says 90%, you have to enter 0.90. Or if it says 99%, you have to enter 0.99. Whatever the confidence level that they give you, that's what you need to enter in this space. Then tab down the sample size, which is N. In this sample problem, number 2 is 806. So you enter 806. And then tab down to the number of successes, which is 492 in that sample problem. Click evaluate. Now, the one that you want will be this right here. the 95% confidence interval using a normal approximation. And make sure that you round off to the number of decimal places that they ask for. And I'm thinking to 3 decimal places. This will be 0.577 to 0.644. And if you were to interpret that, you will have to say that we are 95% confident that the true number or the true percentage or the true proportion of individuals or respondents who chose the window seat as their favorite seat falls between 0.577 and 0.644. Okay. All right, that's very important. All right, now on to problem number 3. It says here, a physician wants to develop criteria for determining whether a patient's body mass index or BMI is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample BMI data set number 1, which is body measurements for male and female on StatDisk. That's where it's located. And you will answer these three questions. Construct and interpret a 99% confidence interval estimate of the mean BMI for males, and B, a same 99% confidence interval estimate of the mean BMI for females. And you want to compare those preceding results and conclude that the proportion of mean, or can we conclude that the means of the populations for males and females are different? Why or why not? Okay, so now let's go to StatDisk. All right, so here we need to retrieve the data set for males and females. And we're dealing with the body mass index in this case. And whatever they ask for, whatever data set that they want, you have to use that one. If it's pulse rates, you have to use pulse rates. Okay. If it's LDL, you must use LDL. Whatever they ask for in MyMathLab. Okay. Now, let's go to data sets. We're using the 13th edition of elementary statistics. Okay. Keep that in mind. The 13th edition of elementary statistics is what we're using. I'm sorry, the 12th edition, not the 13th, the 12th edition. So it's this one we want. Go to body mass, body measurements for male. Let's start with that. Okay. Now, the one that we're going to be focusing on in this problem is BMI, which is over here on the far right, BMI. And let's start with the descriptive statistics. So we're going to go to data and then explore data, which is descriptive statistics. And then the one we want to select would be BMI, which is right here. And then click evaluate. Okay. Now, if you look at the bottom, they give you the 95% confidence interval for the mean and the standard deviation. In this case, you don't want that. You want the 99% confidence interval. So there are 2 things that you're going to need. And by the way, we're going to be doing a confidence interval for the mean. So you need 2 things. The mean, let's say to 1 decimal place, That's going to be 26.6. You also need this, the standard deviation, which is in this case 5.36, rounded to 2 decimal places. Okay, it says 5.35944, but the 2 decimal places is going to be 5.36. Okay, so it's the 2 things you're going to need here. Now, we're going to go back to analysis, go to confidence intervals. We want, this time, we're dealing with a confidence interval for a population mean. So it's going to be the mean one sample, because we're dealing with a single sample here. And you're going to see this looks like this, mean one sample. The confidence interval, now in this problem, sample problem number 3, it says construct and interpret at 99%. Here they're giving you 0.95 as a default, so that means you need to change this to 99% or 0.99. Tab down. The sample size, which is n. In this case, it was 40 because there were 40 data values in that sample. Sample mean, when we did the descriptive statistics, we came up with 26.6. So we're going to say 26.60. We're going to type that in. And then the sample standard deviation from that descriptive statistics screen, it came out to be 5.36. Now the population standard deviation, we're going to leave this blank because we will never know the standard deviation of the entire population. We're not interested in that. So click evaluate. And this will be your 99% confidence interval for the body mass index of males. So to interpret that, we want to say that we are 99% confident that the true population mean body mass index for males falls between, and this is approximately 24.31 and approximately 28.94. So that's for men, which was part A. Now for females, it's going to be part B. Okay, so here we have to go back to Datasets, use the 12th edition of elementary statistics, click on that, and choose 1A, which is body measurements for females. Click on that. And the BMI column is on the far right. Okay. Now we got to do the descriptive statistics there. So we go to data, explore data statistics, descriptive statistics, and under the select, go to BMI. Click evaluate. Okay, we want a 99% confidence interval. So that means the mean is right here. Let's say the 2 decimal places, this is going to be 28.44. And then we also need the standard deviation, which is right here. I'm going to say the 2 decimal places, 7.39. And we're also going to need that sample size, which is up here. That's 40. Okay. So now we can do the confidence interval. Let's go to analysis at the very top. Select confidence interval, click on that. It is a mean for one sample. Okay. You'll select that one, mean one sample. All right. Now we're still doing a 99% confidence interval, so we have to select we have to type in 0.99. The default was 95% or 0.95. So you have to change it to 0.99. Go down to sample size. There were 40 data values that we were looking for BMI. The sample mean was at 28.44. We're going to type that in from the descriptive statistics. And then the sample standard deviation, 7.39. Type that in, round it to 2 decimal places. The population standard deviation is always left blank. So click on evaluate. And this is your confidence interval right here for the BMI of females. So we can interpret that as saying that we are 99% confident that the true BMI for females falls between approximately 25.28 and approximately 31.60. Okay. Now, in Part C, they do ask for you to compare the preceding results and ask your answer, can we conclude that the population mean for males and females are different? Why or why not? Okay. Now, you'll just have a choice of answers for Part C. It could be a case where there might be an overlap in the confidence interval limits, or there may not be an overlap in the confidence interval limits. Okay. So it's a yes or no with a reason where there might be an overlap or there may not be an overlap. So you just have to choose the correct answer on that. Okay, so that is all of sample problem number 3. Okay, sample problem number 4. As a manufacturer of golf equipment, the Spalding Corporation wants to estimate the proportion of golfers who are left-handed. How many golfers must be surveyed if we want 95% confidence that the sample proportion has a margin of error of 2 percentage points? Okay, so here we're trying to come up with a sample size determination. Okay, we can do that in StatDisk. All right, so let's go there. Okay, so now we need to click on Analysis. And here we got Sample Size Determination. That's the one we want to select. Click on that. Now, we have a choice, either an estimate for a proportion, estimate for a mean, or an estimate for a standard deviation. Okay, we're looking at an estimate for a proportion because we're estimating the proportion of golfers who are left-handed. So we select estimate for proportion. Click on that. So here we have confidence level, and it's given as 95%. So you can either type in 0.95 or just leave it as it is because they give you the default of 0.95 as a default confidence level. If it's 99%, you have to change it to 0.99. Or if it's 90%, you have to change it to 0.90. And then for the margin of error, it says 2 percentage points. 2%. Think about this. 2% as a decimal would be 2 divided by 100 or 0.23. I mean 0.02. So we need to change this to 0.02. The estimate of P is not known. We leave that blank in this particular problem. The population size is not known. Again, we leave that blank. So click on Evaluate. Okay. We're assuming a proportion of 0.5, so the required sample size is this number, 2,401. Okay. So for this particular case, 2,401 golfers must be surveyed if we want 95% confidence that the sample proportion has a margin of error of 2 percentage points. Okay. So that's a simple, straightforward answer for that you'll type in the box in MyMathLab. Okay. All right, let's go to sample problem number 5. I think this is the last one in this video. As a manufacturer of golf equipment, the Spalding Corporation wants to estimate the proportion of golfers who are left-handed. Okay. How many golfers must be surveyed if we want 90% confidence that the sample proportion has a margin of error of no more than 3 percentage points? So here are 3 parts. We want to assume in part A that there is no available information that could be used as an estimate of p hat, which is the sample proportion. Part B, assume that we have an estimate of p hat found from a previous study that suggests that 15% of golfers are left-handed. And part C, does the additional study information from part B have much effect on the sample size that is required? Okay. So here we're going to be answering parts A, B, and C. All right, so let me go to this and then go to StatDisk, share. All right, so now let's start by going to analysis and sample size determination. We're still dealing with a proportion in this case. We're dealing with a sample proportion, by the way, so we need to select estimate proportion and then go to confidence level. And in this case here, we're dealing with 90%. So we need to change that to 0.90. And then your margin of error, no more than 3 percentage points. So 3% as a decimal will be 0.03. Now, in part A, we know we have no available information that can be used to estimate p hat. So the estimate of p has to be blank. The population size is always going to be blank. So let's click evaluate. And that would be your required sample size of 752 in this case. So that would be part A. Now in part B, we assume that there is an estimate of p hat found in a previous study that suggests 15% of golfers are left-handed. So the 0.90, which is your confidence level as a decimal, remains the same. The margin of error of 0.03 remains the same. But the estimate of P, we need to enter that in because we are given that 15% of golfers are left-handed from a former study. 15% as a decimal will be 0.15. Population size remains blank. Click evaluate. Now you have a required sample size of 384. Okay. So now we can answer part C. And here I'm going to delete this to get the other 752, which was part A. And of course, click evaluate. When I type in that 0.15, you'll see that the sample size has decreased. So in part C, does the additional study information from part B have much effect on the sample size that is required? And in this case, it did. Because in this case here, when we added that additional survey information from part B, that reduced the sample size in this case. All right. So that will finish this video on how we can use StatDisk to complete the StatDisk assignment number 3 in MyMathLab. This should help you in completing that assignment. So feel free to email me or contact me if you have any questions about the assignment.